And with slow freezing, I always felt that was somewhat of an unknown. We never knew how an embryo was going to thaw. And it seemed to vary a lot from patient to patient, or even from one embryo to the next. You might thaw one embryo and get no survival, and then you thaw the next embryo and it's perfect, survives perfect. And maybe some of that was technique related, I don't know, but the procedure never worked really efficiently in the lab. Vitrification is a much more reliable technology. And even on day 3 for those 8-cell embryos, it's very rare to warm up a vitrified 8-cell embryo and find any dead cells. I mean, they tolerate the procedure miraculously well compared to how they tolerated slow freezing. So I think, for any embryologist, once they start vitrifying embryos, after a very short time, after just a few weeks or a few months, they'll look back and they'll say, why did we keep slow freezing for so long? This technology is just so much more reliable, so much more dependable. And, in the old days when we would thaw some slow frozen embryos, an embryologist could spend half the day trying to thaw one embryo for a patient that doesn't survive. Okay, start again, thaw another embryo, doesn't look so good, thaw again. You could spend a lot of hours just trying to get some embryos ready for a patient. With vitrification, that almost never happens. You thaw one embryo, it's done. It's a 20-minute procedure.
Thank you.
I think this is important. The difference in terms of total survival rate of slow frozen versus vitrified cryopreserved blastocysts is actually not that much higher from the vitrification process. But the other important thing, and Joe mentioned the cells that die in the cleavage stage embryos, you see this if you have to look carefully following slow freezing. You may have an embryo that survives, but it was much more common from slow freezing to have some cells which were lyes, were degenerate following that procedure. You may have as many as 20% of the cells in a blastocyst might be dead, but you would still transfer that. So there is much higher rate of partial survival following slow freezing. With vitrification, it's much more all or nothing. So the 2 to 5% that don't survive, dead. The ones that survive are virtually all 100% surviving in terms of their cells. So this I think is important in giving more potential viability to these embryos following
the quality of embryo.
Yes.
Okay.
I have a question for Brian.
Go.
Get you before you get me. I like your talk very much. Very interesting. Egg freezing for fertility preservation, is that something that's happening in Italy or not so much?
It's very, the idea is, it's very hot. I think nobody's doing it.
Nobody's doing it?
Not really.
No?
Seriously.
But it's legal. You're allowed to do it?
Right. That's
Yeah.
well, it started in Italy, didn't it? Because of the law.
Yeah.
So the groups from Bologna started off. That's what they did. Apparently reasonable. It was the first was slow freezing with sites with iron sucrose. We started a program with Jacques Cohen, and we're doing the Chinese study for choline for children. That still worked quite well. Slow freezing. But outside freezing is very popular in Europe, I'd say. But we don't do it yet as a commercial. Offering to patients. It seems to me that everybody says they do it, but I don't really see anybody really doing it. If somebody really had a technique of doing it, they're the richest people in the world in this moment. So there's a lot of talk, but nobody's really doing it. So if you can do it, let's collaborate.
Well, I think we can do it, but what's sort of interesting to me is, one of the things you mentioned in your talk was, taking, a little bit of cytoplasm from a young egg and using that to donate cytoplasm to an older egg. And I wonder if a young woman, say here in Italy, could freeze a couple of eggs, not do a full-blown IVF cycle, but maybe do a natural cycle, IVF cycle, and freeze an egg or two, and then those eggs could be used as potential cytoplasts that could be fused with eggs in future years if she was to come back and do IVF as an older patient.
No, that's a nice idea.
Just you.
No, absolutely.
Yeah, you just put that away and you have those little cytoplasts, so now you come back at age 45 and you're ready to have your family and you've got your little cytoplasts that you can donate. So.
Good idea, I'll go for that. Quick question for Michael. The embryoscope, okay? This is the big selling point of the world at the moment, follow the embryos. But if you're me, I think we'll go on to one step. If you've got one step needed, we take everything to blastocysts, or just leave them all in there and take them off. You're not going to touch them. You know what I mean? Why do you need an embryoscope? Who would then buy an embryoscope? You know, in the sense, yes, for research, great. But for commercial IVF unit, why do I need to see what the embryos are doing when I can just go for the endpoint, so that's nice, blastocyst, transfer this?
No, that's a very valid point. And I think Joe mentioned earlier that ultimately, though, what we want to do is be able to define certain developmental milestones earlier in development and be able to predict at a high potential which are going to be best blastocysts. Therefore, we remove the need for the extended culture. And so this type of equipment, and there are many, well, not many, there are one or two other companies out there trying to catch up with Unisense. The most notable one is based out of San Francisco, Palo Alto, called Oxygen, where they claim, what is the predictability of
93%.
They have an algorithm based on the first 2 days of development, so 2/4, which will predict at a 93% rate the best blastocysts. So that's why.
Right.
And therefore, you know, the problem in a clinic such as busy as ours in Shady Grove, there is no way we could commit all our embryos to the Unisense machine, because we would need probably 18 to 20 of them to accommodate at any given time.
100K.
They're in the 70 to 100K dollar range. But ultimately, I think that the value of being able to transfer embryos earlier, quite apart from any concerns with epigenetic problems, is simply that in a big lab like Shady Grove, if we did not grow the embryos out to day 6, we would cut down, when we transferred everything on day 2, we would need many fewer incubators. Does that make sense?
No.
We may need fewer embryologists because there's less work to do in the lab. So, you know, it's still a process.
Do you think the states that sort of pushed us towards blastocysts are going to they're going to go back?
Yes, I think so. So the oxygen system that Michael just mentioned, they could tell from day 1 to day 2. If you watch the embryos from day 1 to day 2, and you see the fertilized egg divided in 2, and then you get the 3-cell stage and 4-cell stage, they can tell through those 3-cell division events, the 1 to 2, 2 to 3, and 3 to 4, they can tell, watching those cell division events with 93% efficiency, which of those day 2 embryos will then be blastocyst. And to me, that's very exciting, because it means that we can go back to doing day 2 transfers again. Right? See, the thing I worry about, and you know, we talked a little bit about this with the embryologists in Barcelona and Milan, about, you know, doing vitrification on day 2 or day 3. It probably would mean, or doing transfers on day 2 or day 3, it would probably mean we'd be putting a lot more embryos into the freezer, because a lot more embryos would still look good on day 2 and day 3. But if we have some technology that we can visualize the cell divisions and tell on day 2, all right, this embryo is healthy, this embryo is not, then we wouldn't end up putting all those embryos in the freezer. We'd only end up freezing embryos that are predicted to be healthy. And then the embryos that are not predicted to be healthy, you could perhaps keep those in the lab, because some of them probably would turn out to be okay. But you know, this technology to me is very exciting, because we can go back to doing earlier embryo transfers. You don't get the epigenetic effects of the long culture time, so potentially we get healthier children as a result, and we still end up with no more embryos in the freezer. So I like that a lot.
But did you have an improvement of implantation rate with the embryoscope? Did you note this statistically?
We only received FDA approval to use it clinically towards the end of last year. We are currently doing cases. We can put up to 6 patients
good.
in the one machine we have. So we're actually currently in a controlled trial moving forward to compare the machine and discover certain predictive elements through the first
Also because
trial.
the information of embryoscope are not so large, you know.
No, but
On the number of the embryos that they
right. I mean, most notably, the EV group from Valencia has published on this, but they would be the first people to admit that there needs to be a wider global
So there is
experience.
also a research approach now.
Yes.
Can I ask a question on your
Yes.
very nice
Yes.
endometriosis
Yes.
talk? I enjoyed
Yes.
it very much. The amount of BPA that you expose the mice to, how much water would I have to drink to get the silicone? Or what is the
Depend on the temperature of the water. If the water
If
is
the water is sitting in the sun?
vitrificated, no BPA. The warm makes
the
the
BPA go into
BPA
the
in the water.
Yeah. So how much exact? I mean, how many bottles of water equivalent are we
No,
talking
but
about? to get the
listen,
silicone?
there is a there is a substantial difference because in adult people the hepatic glycuronation eliminate the endocrine disruptors, but embryos have not hepatic glycuronation. Is just in the beginning of the life. So the damage is for the embryos,
Well, because,
not for the adults.
we expose embryos to a lot of plastic. I mean,
This is a problem. It's a problem because there are studies before our study that they look in the cord, in the umbilical cord, the amount of endocrine disruptors, and they are 25-30% more high than in the blood of the mother. So there is accumulation in the placenta and in the embryo of the endocrine disruptors. And of course, if you use that kind of plastic, should be toxic.
Could be.
Could be.
And
toxic.
I mean, I didn't show the data, but
Yes, we have.
we have data that the mice, the treated mice, the pups,
Yes.
they have BPA in the body.
Yes, we have another study that we look at the amount of BPA in all tissue, and we know that in the brain and also in the muscle, no, there are a large amount of BPA because there are the tissue that are particularly, responsive.
Yeah. And this, I mean, nobody knows exactly the reason. And also there is a little gender difference in the accumulation.
Yes.
Because we did also on male
Yes,
pups.
yes. So the
It's a little-
females accumulate more
in different places.
in different places.
In different places.
What endocrine disruptors are these products already banned by various governments? Are they, I mean, is plastic safe now?
The government, the European community took away the BPA from biberon for neonati, for child, for babies,
Babies
for
bottles
baby,
of-
yes, biberon.
Oh, okay. That's
And,
fire resistant, would say.
just for that. Because the governative committee evaluated the effects of BPA on adult people, on adult campione, capito? They did not evaluate the studies in embryo or in pregnancy on the fetuses.
Yeah, and they also look at just at toxic effect. We are not talking about toxic
Right.
effect, but molecular
There
effect.
is an interesting paper on WHO on endocrine disruptors, very large papers there on all the disease that this kind of contamination makes on human health.
It's a big problem.
Yes, I think so.